Hello everyone. In this class, we are going to talk about EDA. Till now, we have completed NumPy, Pandas, and Matplotlib. Now, what we have to do is where we can use all these three main modules for the data science. Like, see, there are n number of modules present for data analysis, right? But why we learn this is to process the data or to train the machine learning model. So we need definitely all these three to do the data analysis, right? I wrote over here. Now the next point comes over here. Okay, what does this data analysis means? For this, here comes a picture of a term known as EDA, Exploratory Data Analysis. It's like what the data you are having now, any data set or something, you have to before training it to a machine learning model, you must know okay, what are the data it is consisting of, how many null features and null values are there, okay, how many categorical features are there, how many numerical features are there. What does this mean? Categorical and numerical means, for example, gender. If a data set of some school, okay, let's say we have a data set of a school in which we have age, ID, gender, class, then height, then weight. So if this is our data set of any school consisting of this number of attributes or features or columns, so here what we have to do, we have to find which one is the most important, or like for the machine learning model. See, for ID card doesn't matter for a machine learning model to predict okay, is this school children is healthy or not. For example, let's say we are going to create a machine learning model which can able to predict on the basis of some biological details that this child is happy or not happy. Let's say it's an example. So we are having age, gender, class, height, weight, and let's say one extra depression count. Okay, is the person is depressed or not? So is child happy or not? It will predict on the base of this. So over here we can see ID doesn't matter, and class at a for some like for some extent it doesn't matter. This class doesn't matter. Okay, the thing matter is age, gender, sometimes height doesn't matters, but still weight can define your is the person is healthy or malnutrition. So is there any case in which the malnutrition people are more depressed or are not happy? So we have to check for the different columns, which are the main columns which play a vital role for the machine learning model, right? So okay, to categorize, see, age will consist age column will have data something like 18, 16, 14 or 13. So this will be a numerical value, right? So it will come in numerical category, this category. But let's say gender consists of two categories mainly, that is male and female. So it is a category, right? Either male or either female. So either in this or either in this. So what will happen now? Okay, we can't classify right now. So it will come under categorical data. Okay. Or class will come under categorical data. Okay, class 12A, let's say including the section. So it highly doesn't matter, but this can be a vital role, that gender part, right? So we have to filter out which are the important uh, columns or the features which play vital role in deciding a machine learning model. For example, let's say you are having the same data set but this time with name as well. So name doesn't play any role, right? Okay, if your name is Aditya, you will be less depressed. If your name is, let's say, Salman, you'll be more depressed. Not like this, right? So what we will do, but we can't give this data set as it is to the machine learning model, right? Okay, now we will train as it is. So we have to remove the unnecessary part, unnecessary data, let's say the name one. Then we might have to remove the ID card number because that also doesn't define how the person is happy or not, or depressed or not, let's say. So what are the important features we have to take in consideration while deploying a machine learning model or training a machine learning model, and which are the features we should drop or we should don't take care of. Okay, this is the first part. Now the second part comes ki, okay, if the gender are categorical, right, either male or either female, but computer only understands 0 and 1, right? It doesn't understands what is a male, what is a female, right? So how can we deal with this type? Or let's say okay, a data set is there in which n number of patients data set is there of heart disease, right? Heart disease. So in this there is a feature called chest pain. I gave example in AI works also, chest pain. If a person is having a chest pain, but what type of chest pain? The first category, that is the low level, you can for now you can assume like this, but there are n number of okay. So second level or third level, mid angina, then fourth level is high level. So which type of chest pain is occurring? So this is the one point. Let's say another point, okay, this male and female, or somewhere if you're finding a categorical data, let's say students, or like this only, this heart disease, okay, some of them were let's say students, some of them were old age people, some of them were professors, example. So which type of the data, see, computer can't understand what is student, right? So we have to convert this into some numerical value, let's say 1, or for old age we will say 2, let's say for professor 3, okay, how many total, let's say professors are 100 in this data set of 500 total, and students, let's say 390, that is 490, and 10 are only old age people. So most of them are consisting of student, but unless you convert this categorical data into numerical data, you can't train your model, because a machine learning model can't understand what a student is or what this value denotes to. It can only find a relation. See what happens, no, at the back end for a data, a machine learning model nothing do, like algo you can say, it just find the relation between what the data columns, right? What the data we have, for all the data it finds a relation, what is the common relation, such that if let's say for the heart disease only, if your age increases, then chances of heart disease also increases, right? Same part, okay, these two are correlated, like okay, if one increases then other also increases. Say I'm telling you the third part, right? Same way, what are the main features which are dependent upon each other, or let's say uh, okay, let's say activeness, how much a person can be active, okay. So as the age increases, person activity or activeness definitely decreases, right? So this is inversely proportional, like if age increases, then this activeness decreases, which means this is inversely proportional to 1 upon this, right? So एक बढ़ेगा तो दूसरा घटेगा. The same way, so how you can deal with this feature? So to find the best ML model, ML model, you definitely have to clean this data set, first part. Second, do the pre-processing. Pre-processing consists of all these things what I have just told. Then only you can go for the analysis part. Okay, now we'll do the analysis. Now everything looks fine, then only we will go for the machine learning training model, right? If you go directly with the raw data to machine learning part, then there will be high chances that your model is not up to point, or like it will not work as intended. It has to be, like it has to work. So this is the main point why we do EDA, that exploratory data analysis. We do exploratory data analysis to know much more about our data. Okay, how our data looks like, what are the main key features, what are the main columns, or what are the rows we have. Okay, how many rows are not, let's say if we have data set, might be a case where some of the rows can be empty, like this row is totally empty, and some columns might be empty. This column, let's say some data is here, some data is here, this all of it, but this are, so how can we deal with? So all comes under the process of exploratory data analysis. right? To do pre-processing, to make the parameters more clear, to do the feature engineering also, to select the features which are more better for the machine learning. So everything comes on the one topic, that is EDA. If you don't do EDA, if you miss the EDA, then definitely your machine learning model is going to fail, or it will give you less accuracy. So if you want to boost your model's accuracy, definitely you perform EDA n number of times with n number of different ways. Okay, so this is right now this is an intro class of EDA. I'll show you the basic parts how EDA has done on one of our project or live class. Then after this we'll take up one more class in which we will talk about EDA step by step. Okay. So what we do right now in EDA, we understand how the data is structured. Second thing, we identify the missing values or outliers. Okay. So, okay, I didn't teach you what is outlier. Let's say we have a data set of age only, students and age. So age can be this, no, 18, 14, 10, 19, 17, again 18. Okay, that's. This is acceptable. But if you find some of the data at the end, if you are finding, okay, 54 or 32, so a student studying in class 12th can't be a age of 32, right? So this is called outlier. Like the data which are or age of 54, the data which are out of a normal range are known as outliers, right? See, if it is 20, okay, exceptional case. But if it is 25, then we can't. Definitely, it's an outlier. Outlier means which data which lies outside the mean range, or like normal range. That's we say for outliers, right? So definitely, if your model has, if your data has a lot of outliers like 32, 64, 96, or 75, 84, something dash dash dash, that definitely is gonna make this model wrong, because age of a student can't be of this rate. So you have to deal with all the outliers. So if you do the detection early before the training of the machine learning model, definitely it will help you out, right? Okay, then next step is to find the features. What are the main features, like best features which performs, like I told you, as age increases, heart disease chances are increases. So these two are correlated. So can we make them one feature, right? Like multiplying both or having some arithmetic operation in between both of them, and then collectively talking as one feature. So this is known as feature selection and feature engineering. So we will do after EDA. We do feature engineering after exploratory data analysis, right? Basically EDA help you to determine which are the main features which contributes to the best ML output accuracy, ML accuracy output. Right, EDA is the main part which help you to predict the best accuracy from a machine learning part. It will give you the which are the features which are highly correlated, known as heat map. In heat map, we able to find, okay, these are the columns, or these are the things which are highly correlated, right? Then, okay, we'll see one more thing. Let's say our age is something like more focused on 10, 11, 10, 10, 11, 12, dash dash dash, more focused on less than 15. But yeah, in our school we have around 19, the maximum age is 19, but most of the 50% of the data lies between 15, less than 15 years of old, right? So what we have to do, this is called skewness. Okay, skewed, like SKWED, skewed. Yeah, means if your data is not normally distributed, right? Sorry, this will be over here. If your data is not normally distributed, like it should come between, this is nothing but, this is your mean, this is mean plus 1 standard deviation, this another is mean plus 2 times of standard deviation, and this is the mean plus 3 standard deviation. So 99.7% of the data, I think, sorry, 97% of the data lies between, I should write it again, 97% of the data lies between mu plus 3 sigma and mu minus 3 sigma, between this range, right? This is mu minus 3 sigma, this part, and this is mu plus 3 sigma. Sorry, one more will be there. So between this, 97% of the data lies. So occasionally, or like most the actual format, we say that only 3% of the data are outliers, right? So as we can see, it is more skewed towards left, like that is 15 years. Let's say if our 0 or something, it's 10, so it is more over here, the data is more skewed over this side. More of the data we will find over here. But the point is ki for a better model training, we don't need skewed data, we need normally distributed data. That means ki okay, it should follow for this is I think so 67%, this is 95%, and this is 97%. Do cross verify, this is called as normal distribution. Okay, right. And our data should not be like shifted towards one. Okay, let's say bhiya, okay, I got it, okay, there should not be outlier, but this can be also possible, right? Okay, most of the data, see, I'll plot over here numbers. This side is number of data and this side is ages, right? It can be more like okay, the person with age 10, or the data what we have is more in 10 and 11, but less in age of 18 or 19. So as you can see, if you draw, if our data starts from this part only, 0, then 10, then 11, then you can see this will be the curve, right? So it is left skewed. If it is right skewed, it will look like this. I'll put like this. No, it will look like this. So you need to make both left and right skewed matrix, graph, to look like normalized like this way, right? So this is how to remove the skew. See, there are n number of ways. I am just right now giving you the outlook of the EDA. After this, I'll show you how EDA is performed, and then in the next class, what are the main ways, or step by step how we perform EDA, right? So these are the basic thing. Why we do EDA, or why we remove outliers, and why we do remove skewness of the data. The reason is that if you do like this, no, your computer will be more biased. Computer will be biased toward particular result. For example, if you feed 10 and 11 data more and less of 18, 19, so whatever the data you feed for the prediction, now it will give you more, like slightly more focus to 10, 11, because it has n number of cases for it, right? But for this, it is having around n by 2, or let's say n by 3 cases only. So this will be biased, computer will be biased towards it. So this is the first reason. Second reason is that this is only known as overfitting, right? Second thing I told, no, this 0 and 1, we have to change gender male to 0 and 1, right? Because computer can't understand English, so everything we have to encode. That is known as encoding. There is one more thing called encoding, when we have to convert categorical data to numerical data. What does this means? Categorical data, I told you, just like male and female, so computer can't understand male and female, but instead we can denote male as 0 and female as 1. Right now computer can understand this. So these are the main thing. To train our ML, we need to do EDA. These are the main reasons. Again, if you know your data, the main part is what the data we have, proper visualization is needed, right? We have to do proper visualization. We use pie chart, scatter plot, histograms, bar chart, same thing, line chart, to get the best out of it, right? Yeah. See, it's like if you don't do EDA, before doing ML, definitely you're like like driving a car with its headlight off in the dark night. Yeah, definitely you will reach somewhere, but you don't know where. So that's why EDA is important. I'll show you the example. You better check this out. See, right now, for those who are having problem in importing the dataset, it's easy. Just you have, let's say this is the IPL dataset. Go over here, click on this download button. Click on any of the, let's say I have downloaded deliveries. Let's say I have to download matches. Click on it. Click on this download button. It will start downloading. See, for this it's reader available. Okay, sometime it may show you as the reader available, but most of the time it will start downloading. Yeah, see, right now it started downloading. Yeah, deliveries only. right now what you have to do, go sample ed or anything, create a new notebook, go over this icon, click on it, click on this icon, that is upload icon. Okay, or either you will click over here also and upload, not over here, over here, new folder, or in sample data also you can upload. Just click on upload, select the file type, that is CSV, click on upload. So I have already uploaded, so this way it will be uploaded over here. Now you want to read this, click on this three dot, copy path. Okay, import the basic libraries, that is NumPy, Pandas, Matplotlib, and Seaborn. I'll tell you what is Seaborn. And then df is equal to pd.readcsv. If the format is .csv at the end, use readcsv. Else, if it is XLSS form, you have to replace it with XLSS form. Then pass the path of the data what we have over here. Just paste Control V. You'll get the path. Press Shift Enter. So now the data is being read by the Pandas and it will be stored in the data frame, that is df, our variable name. So this is how you can import the data, right? And if you want to check okay how the data look like, just put df, you'll get a data frame look. See, this is the way df look like, or data frame look like, right? So okay, this is the way. See, ED is nothing but the combination of NumPy, Panda, Matplotlib. Seaborn is nothing but the advance of Matplotlib, where we have a tons of feature which help us to do more machine learning types. It's similar to Matplotlib. It's used for the visualization only. It has nearly same features, but as the Matplotlib earlier, right now it's in the third update or fourth update. So before this third update, what happened? Matplotlib paused for some time. So Seaborn come as a leader and started to help people visualize their data in more effective and easy way. That's why more people use Seaborn as SNS, but you can do Matplotlib as well. Okay, then it's easy. That Seaborn command is also easy. This is the way, and I was just preparing for the next class for this one, but right now we'll see. Okay, df.head gives you the first 5 columns of your data, first 5 rows of the data. Okay, with all the columns what it have. See, we can have player dismissed kind. See, it's a NaN, not a number, right? A data type. So we have to deal with NaN values because we can't train our machine learning models on a not a number value, right? Definitely. And SC Ganguly, non-striker, BB McCullum, I don't know, but yeah, see, RCB, bowling team was RCB, batting team is Kolkata Knight Riders. So you can't train model on the object data type, right? You have to convert into the integer or float. So either what are the teams under the batting, you find it out, encode it, okay, Kolkata Knight Riders is 0, or RCB is there, or CSK is there, 1, 2, 3, like this encoding you have to do, right? Then df.info, this is the way you can get okay how many entries are there. I told you in the Panda session, sorry. So as you can see, these are this much of the non-null values, means this contains some values, not like these are the numbers. Okay, integer 64, integer 64. Object means string data. Bowling team, as I showed you. I don't know English, but yeah. See over here, batting team. Over here you can find Kolkata Knight Riders. It's in string, right? So again object. Again bowling team is also object. So computer can't understand object data type, right? So we have to convert it into integer or float or any type of data, which can be easily understood by the computer. So this is called encoding. Right, after this we find okay how many null entries are there in this. See over here, there is a huge drop from 2,60,920 to 14,125, right? So yeah, see, this much of the data are not available. In this also not available. So either we can drop this, either we can replace some values with the mean or mode or something. So median. Okay, now df.describe what it does. It converts it finds these features: count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and maximum of the numerical data. See, these are the numerical data. You over here you can't find bowling team or what was the other, batting team, right? Over here you can't find these because these are the categorical data with the data type as an object, right? So all the numerical values only will be displayed over here because you can't find mean of the RCB and CSK, right? So that's why categorical value is not considered over here. Okay, after this we have extra type dot is null means okay, tell me in the extra type there is a feature where it went, yeah, extras type. Okay, how many null values are present in the extra types? See over here, if you go in the extra types where it is, you'll find all the values as nan, right? So if you want to find, okay, in batting team how many are the null, so definitely it was 0. Yeah. So else fielder, let's say for fielder, if you want to check how many fielders values are null in our data type, data frame, just put over, replace it, you'll find fielder name will be missing over here. Where is fielder? I'll go down. Yeah, see fielder is nan. So if we have to replace all the nan values, we have to perform exploratory data analysis. Then only we can go for the training, right? df.extra-type.value count, it will give you the total number of extra values in this, how many different types are there and their values, right? See, for example, we want to check for how many batting teams are there and their count, right? Go like this. See, we have this much of Mumbai Indians. How many times Mumbai Indian has been the batting team is 31437. Kolkata Knight Rider as batting team 29514. The least is Rising Pune Super Giants 1580. Right. And see, this is also is counting and this is also counting. Why this is the same name, but why? So because over here there is no S, but over here this is S, but both indicates to the same team, right? So how we can merge both of them data? This is only the EDA part. So it's a big task. It's not a small task. And over here I can show you one of the thing, like this is the student depression data set. Over here these are the non-null values. First it was null values. See over here you can find 27898 and 27901, 3 null values were there. So how we can remove these 3 null values? And then okay, we over here as you can see now it is converted to 27901. So we replaced it and now all the null values are zeros. Okay, how many different genders are there? So we have male and female, how much count is there? Then we plotted a chart. Okay, count how many as a graphical representation of gender distribution, right? 16,000 and female around. So yeah, then degree, how many degrees are there and their count, how many people are pursuing that degree. Okay, there is a function known as group by where we add 2 or more than 2 columns in together to get a better view, right? So this is the way how we do the EDA part, right? Again we do the describe, and why there is T, because I want to transpose of it. If I remove this T, I think so it's not connected. Okay, I'll do over here in this. If you do, where is df.describe? See, right now count, mean, standard deviation are coming here and all the columns name are coming at the top. I just put dot T and I'll shift enter. See, now it's got replaced. That is the transpose. So it will give you the better way. Okay, match ID count is this much. What is the match ID mean? This much. 25 percentile. Or ball mean is this. Ball count is there. Extra runs, total extra runs were 260920. How many entries are there? So for the extra run, this much. What is the mean? The 0.067. Okay, what is the maximum? So 7 extra runs went in some match or something. So this is the way you can do the analysis. Then comes this histogram type. In this we have to give okay, I want to plot the distribution of age between frequency. Okay, how much people were having at the frequency means how many times we are getting. There will be a okay, how many numbers? Frequency is nothing but the number of people for between this age, right? Around 3200 age. This is nearly 4000. Then okay, leave this. And the main thing, this is outlier. See, if the data have age more than required, see, these are the outliers. This is known as box plot, in which box plot is used to find the outliers. So outliers will be denoted as the outer circles outside this mean range. I told you, no? Okay, if this is the normal range, if the data is present outside this, is known as outliers. Okay, this is the another way to find outliers. This is called IQR. Okay, this is the another way, and again this is called heat map. Heat map is nothing but what is the correlation, or like what is the relation or dependency of one feature with another feature. See, one feature with same with himself or itself will be one, right? Because If it increases, it will increase. That is 1 1 1 1. That's why cross cross cross. So if depression increases, then depression increases. That is 1. If decreases, then it decreases. But if you see work pressure, as the job satisfaction increases, work pressure also increases. What is this negative signs means? If job satisfaction decreases, CGPA increases, or like CGPA increases, then job satisfaction decreases. This is the negative correlation. So we have to check, okay, is this the point satisfactory or not? See, as the academic pressure decreases, study satisfaction increases. Definitely, if work study hours increases, then academic pressure definitely increases. So this is how you can see, okay, what is the correlation, or at what rate this, the numerical value says the rate, at what rate it increases, right? Is it 100% कि हल्का सा बढ़ा तो वो भी हल्का सा बढ़ जाएगा, और इज इट लाइक कि ये थोड़ा बढ़ा तो वो हल्का बढ़ेगा, लाइक उस ये पूरा बढ़ा तो वो थोड़ा सा बढ़ेगा. दैट इज द कोरिलेशन और डिपेंडेंसी यू कैन से. So that's the another part. Then okay, I'll tell you this at the last. This is nothing but ki when we have the target value, ki the person is depressed or not. So is it equally distributed? If not, so how we can distribute equally? Then how we can drop? See, at the starting we have how many columns? We have around 17 columns, but we dropped some of them because we didn't need. So right now these are in object, float, object, but at the end you can see over here only everything is now in integer float, integer float. So this is called encoding. We converted all the object string type into encoding type, right? For example, diet mapping, healthy we map to 2, moderate we map to 1, unhealthy map to 0, others is mapped to 3. So those who are eating healthy, now it is mapped to 2. Okay, the values is swapped now. Then again we plotted the EDA graph, so sorry, heat map graph to get the feature selection. Yeah, same thing. So this is from right now, today's end, and some of the resources are already shared in the group. I'll share some more resources, and go definitely try some of the things, right? Definitely I'm thinking of making a PPT because it consists of a lot of things: data pre-processing, data analyzing, data visualization, data cleaning, so, and then doing again and again, doing feature selection. A lot of things are there, right, in this exploratory data analysis, and slowly we'll cover everything. This was the intro part, right? So you can expect we will cover it by 1 week or something, right? So yeah, and let me open one more thing here: data sourcing, then data cleaning, that categorical analysis, then numerical analysis, then derived matrices. Okay, where we can collect the data, how, like data sourcing means, is it private data or is it government data? Let's say if many government websites give you the data. If you search the government data sets, see you got. So many of the Indian government also gives you the data set to analyze and to increase the sales and all, right? You can download it, CSV file or whatever you want. Just click on it, it will start download. So yeah, but I don't want, I'll just cancel it. Then how we can handle the missing values. Over here we talk null values, how we can deal with the null values, or do we have to replace it, or do we have to drop it, or is there any algorithms which will help to do it automatically so we don't have to do something. Let's say if this is null, so can we make prediction ki Kolkata Knight Riders, Royal Challenger Bangalore, and same thing, so it will be wide or something, or it will be a dot ball or something, I don't know, but yeah, I'm just guessing it. So we can predict it also, no? Okay, before this, all the values what we have, for example, removing this NaN right now, the trained one with all the values we have, we will train a model and we'll predict for this data part, this input, and we'll definitely get the output, right? Then there is feature scaling. If the values in this, I think so, this is not present. Okay, if the some datas are like, I'll show you one more thing. I taught this also. I'll add this. Where is my? See, in case if some data looks like 150, 900, or let's say some score is there or some percentage is there or anything. Somebody's score is 150, somebody's score is 989, somebody's score is 600. So that again, computer will be biased towards the larger values while training. So we have to call it to a particular values. Let's say the maximum will be 1 and the least will be 0. So 989 divided by 989 is 1. 900 divided by 989, we will get some values. This will be 0. Let's say 98, or let's say 9 or 8 something. Then 600 divided by 989, this will be some value 0.4. let's say this is 0.8, this is 0.4, and this is 0. Now the computer will be not biased towards 1, because there for 0 and 1 it considered equally both, right? But as a number increases from 1 to 989, definitely it will become biased towards it. So this is called scaling. Okay, again we have two types of scaling in this, that is standard scaling and min max scaling. So when the topic will come, I'll teach you. Right now just leave this topic. Okay, and most of the probability statistics topics are over here only to cover. Then outliers, I told you. So outliers, one more thing, outliers, we can have this. Okay, how we can detect outliers? We can definitely use box plot, which I showed you right now, like this one. No, if this is the mean, right? This is, I think so, the first one is 25 percentile, this is the 75 percentile, and this is the 50 percentile. And apart from this, all the data are known as outliers. Then again we can use histogram, we can use scatter plot. The first graph I showed in the Matplotlib is, scatter plot was, this is scatter plot. The data will be plotted. So the data which is totally outside from the normal data, see like this, no, the most of the data are lining on this line, but this is the outside data, this is outlier. Same way z score is also there, z is equal to x minus mu by sigma, right? So these are the basic way you can find. So how we can deal with, there are also many ways. Either you can directly remove this data, that is removing the outliers, or either you can replace it with some mean, median, or mode, or use any machine learning model to predict the data. Okay, at this value and this value, what will be the output? So over here we are getting something, this. Okay, so it's a kind of prediction only. And the third step is to either predict. The first step was to remove, delete. Second step was to replace, but how? Mean, median, mode. Or third one is to train a machine learning model on the correct data sets and predict the value of the given input at the given input to get an output. Okay, and replace with this outlier and again train the model, right? Or the fourth way is, okay, definitely we have some machine learning machine learning algorithm which replaces outliers on their own. They treat outliers as, like, you don't have to explicitly teach them how to deal, they will deal it by their end, right? These are the basic important things, and yeah, that's it for today. Let me check if something else is left. See, EDA is just important. Like I'm reading one sentence. EDA is important to analyze the data. It's a first step in a data analysis process. EDA is nothing but a data exploration technique to understand various aspects of the data, and it is an approach to analyze the data set to summarize their main characteristics in form of visual methods, right? Yeah, definitely, it's also true. EDA helps us finding the errors, discovering data, mapping out data structure, finding out anomalies. Anomalies is nothing but outliers, right? Yeah, this is the point. Now let's end this session. Okay, thank you. See you in the next session.